So the point, here's today's title, Holy Cannoli. How do I test all this? Does everybody know what a cannoli is? Have you had one that's actually holy? Have you been to like Little Italy or something? It's like, oh, I love them. All right, I'm Steve, and that's a 0 on the end. That's our, you can find me everywhere at that.
I'm Jason Porter. You can find me LightGuardJP on Twitter, GitHub, pretty much wherever.
Exactly, and then if you want to follow along by yourself or after this talk, that's the bit.ly link to these slides. Okay? So go there, copy it. You can copy it into your, if you're using Google or whatever, you can copy it and make your notes there. If you don't, unless you like paper, in which case you can keep using paper. All right, let's get going. So the goals and the prerequisites. So let's do goals first. The goals is to understand the different types of testing. Oh, it's in the, I'm supposed to read it in the back over there. Goals and understand the different types of testing for microservices architecture. So judging from, I was up in the green room, our fancy green room, upstairs, speaker ready room. Judging from Christian's response when he said, how many of you are doing MSA? It sounded like very few of you are actually doing microservices right now. Is that true? Yes. Okay. So we'll go through that a little bit when we go through here. The goal is also to know how to use the different kinds of tests we're going to introduce, and then add tools to your toolbox is the end, right? All of us, I consider developers like carpenters, right? You don't use a screwdriver for everything you do unless you're like me, and then it's actually a butter knife. And so the goal of this is to give you more tools to reach for when you go to do something that's more appropriate for what you want to do. Your prerequisites are, you know what MSA is. So I'm assuming even though you're not using it, given that you're here, you at least know what microservices, the general idea is. Is that a good assumption? Okay, good. You have testing experience in any language. And by experience, I mean up to you've read a book. That's the bar for experience. So you've read, even though you may not be doing it, you'd be like, I've read about JUnit, and I've read a lot about it. It looks great. Has everybody at least done that? Yeah. So are some of you actually have like big test infrastructures inside? Anybody? I'm assuming some of you must.
I see some heads nodding.
Yeah, okay, we're going to have to make, how many of you are actually doing at least unit testing in your company? Good.
Okay.
Hey, and then who's doing more than unit testing inside their company? And then hands are like much and less. Okay. We expect, as you might notice, Jason and I are informal speakers, so please ask questions as we're going along. And we'll try to remember for the people streaming, and maybe for the people up in the cheap seats, shout out to my people in the cheap seats, that we'll try to repeat the question so everybody can hear it. Okay? And then you're going to you guys already are aware of the last bullet, right? Because you're here for the talk. Who said yeah? That wasn't very nice. You would have said, no, the jokes are great so far. Okay, so why should you care about testing in a microservices architecture? So with a monolith, we care about testing at the unit level, right? And even in a monolith, things are pretty tightly integrated, and it's easy to know where we make, or at least track where we've made changes. As you've seen from a lot of the different talks today, things get spread out all over the place as you start doing microservices, right? And so in the same way that unit testing is your safety net when you're working in a monolith space or when you're working with just functions, the tests we're going to talk about today are what lets you begin to build a microservices architecture with some feeling of a safety net for when you make changes. I can just talk from direct experience. Jason and I were getting our sample app ready. I was the one who had written the sample app originally. We did not have any testing, including unit testing, in place. I don't know who coded it. It's Jason's fault we didn't have it.
That's right.
But as we started trying to get the app to work, there was no safety involved, and it was a very painful process. Like halfway through,
that's right. Go take a look at the commit history and see. Still debugging. Nope, didn't get it. Nope. Oh, maybe. Nope, still not. Still debugging. Yeah.
So it would have given us a lot more sanity trying to debug this and feel comfortable with it had we had the testing in place. Do you guys need more convincing than that about why you need testing for microservices? Do you understand like the scale of what happens when you do with microservices? How many of you are trying to do logging with microservices? And how fun is it? But so the answer was this, and the answer for how fun is it is this, and then the question is, and how hard is it when you don't actually have it? It's really hard to get that, if you don't have distributed logging in place, it's really hard to know what's going on in your app. And the more things become distributed, the more you're going to actually need those safety nets in place, the logging, the metrics, and the testing.
Yep. That's right.
And the other thing that goes with this testing is you should put logging and metrics. We don't have any talk here today on logging and metrics. But without that, like when we were talking about Edson's and Marius's talk, remember how you wanted to chase a database transaction? How do you think that happens in an MSA without logging? System.out.print lines with timestamps. How much fun is that? So this is, again, why microservices brings a whole bunch, and testing will help with that. So the stack, the app for today, I'm not going to actually show it because it's a very, very simple app. I believe in building really simple apps when teaching or introducing a concept because I don't want anything else to get in the way. It's a very simple Dungeons & Dragons character generator that we built. Thank you. It's basically got three services. No, it's got a web page and 2 services.
Yep.
So it's microservices, all right. The web page is just the front end. Jason, I'm assuming, is going to bring it up for us right now.
Yep.
There's the front end. You click on the button on the top. Can you actually increase the font a little bit, please? There we go. So let's generate another character.
And I think they're all going to be named Steve because someone else.
What is it? What other name is there in the world besides Steve that matters? Okay, let's do the next one. Okay, so what this web page is doing is making a call back to a generating service that generates a Dungeons & Dragons character. And then if you go behind the scenes of that, that actually calls into a MongoDB, a service that actually inserts the data into MongoDB.
And this one actually looks like it might somewhat be viable. Maybe.
As an elf?
Elf wizard. Yeah.
So the service, the stack, the app, again, is it generates Dungeons & Dragons characters. There's a service that generates a character. That then talks directly to a service that inserts it into the database for us. And that's the extent of our, so if we actually go to, I think if we go to /admin on this, it might work. Let's hope it does.
I think that's a different service.
We didn't implement that part. It's not implemented yet. So admin, actually, you can call into that Mongo service and get back all the users that are in the database. So that's our microservice app. Does that sound about the same as everybody else's microservice app here?
Nope.
You guys said you weren't doing it so far, so is that about the level you guys have gotten to? Yeah. OK, so you can relate to what we're doing. Now let's go on to the testing. Any questions about the app or anything I've said so far? No, we're good? OK. Oop, the buttons are backwards on this. So these are all the different test types we're going to talk about today. Memorize it. There's a quiz at the end. Just kidding. OK, so we're going to actually start with unit testing next, but we're not going to actually talk about exploratory because it's not really a formal technique. Exploratory is you basically go around and try to break the site yourself, right? Like you're exploring the site, trying to find breakage. We're not going to talk about that much here today because that's actually manual, and you're not going to automate and put that in. That's just kind of testing by your users and people inside. So we're going to start with unit, and then Jason's going to handle all of these. So let's start with unit testing. So your old friend, the unit test, most of you raised your hand at least knowing what a unit test is, right, and probably have used it. Just a quick recap, it's basically testing a function or a method inside of some class. Right? It's just saying I want to exercise within this class or this service this one little call. Right? And the good news for you is it's exactly the same with microservices. So you're already experts in unit testing for microservices. Patch stuff on the back for that. And I'm not going to talk about it anymore because nothing changes. The way you ran unit tests now is the way you'll run unit tests with microservices. Sound good? Okay. We're going to pass on now to Jason with integration testing.
Unless there's questions. If people have questions about microservices, and by all means, ask. Thought I saw a hand, but I guess not. Check up. Nope. All right. We'll go ahead. Integration testing. Who's familiar with doing integration testings in their current applications? There are a few people. All right. Very good. So what are you doing for your integration tests? How are they different from your unit tests? Someone that raised their hands. Yeah. Right. So you've got module A talking to module B talking to module C. That's right. I can remember this. Hey, we got this right. All right. So we're all on the same page. Integrate basically to unite or to combine things. Like you said, we've got modules 1 through 5 talking to each other, and we're going to test to make sure those all work. In a microservices architecture, it's all about integrating boundary layers. Now, when I talk about boundary layers, I'm talking about databases, logging, anything over the network, anything that's kind of not in process or not local. So that's what we're going to be testing as far as integrating boundary layers. We want to make sure in our microservices, because we've got lots of little teeny tiny things floating around everywhere, we want to make sure that they can all communicate, right? If things aren't communicating, then things go down, and we've got circuit breakers and all kinds of fun stuff going around that we've got to make sure everything works. And I cannot read those at all. So like I said, we want to test against persistent stores. We want to make sure if we're talking across the network to our database or to our logging or to our metrics or whatever it is, we want to make sure that we can do that. And also against gateway boundaries. Now, what I'm talking about there with gateways, if I have a service, like in our example app, we're actually making a call against, so our web app is talking to a service which talks to the database. I want to make sure that each of those boundaries right there, if I'm talking over HTTP or UDP or whatever it is, I want to make sure that I've got something in place to test that communication to make sure that it happens when I expect it to happen and make sure if there's any redundancies that all of those are in there. And also, we want our integration tests to be fast. In your current stuff, how fast do your integration tests run? How fast are they? Do integration tests take a while to run? Sorry, what was that? 1 day? 1 day, a whole day to run an integration test? Okay.
So can I ask one question?
Commit and go, and I'll come back tomorrow.
So with your integration tests, are you actually testing between services? That's not what we're talking about with integration testing here.
Right.
It still takes a day? Ow.
Yeah, ouch.
Okay.
Okay. The idea is you make them fast. So if I'm just talking against a database, can I do a select count from whatever? Does that come back quick? Can I do a head or an option HTTP request? Am I just getting things back quickly? That's what we're testing here at the integration boundary areas. Toolbox. For those people currently doing integration tests, what are you using? What kind of tools are you using? JMeter, okay. Anything else? Okay. In-memory databases. How about you guys upstairs? Anyone? Sorry, I missed it? Okay. So some tools that we've got. Mocks. So we can mock out calls to a database. We can mock out calls to Apache or to Nginx, whatever those might be. Stubs, kind of the same idea. Archelion. Who's familiar with Archelion? Anyone heard that before? I see one hand, two hand. You don't count.
That was you, Christian. You don't count.
So one or two. Okay. If we've got time, I'll be talking about Archelion. Yeah, we'll get there. Next up is Docker. Docker. Okay. A few more hands. The idea with Docker for doing integration tests, if I'm talking to a database that I don't happen to have locally, or if I'm going to be talking across the network, I can actually spin that up inside a Docker container that runs on my box, but it still talks over the network. So I can spin that up locally or in my test environment and actually talk to that and make sure things are up and running. And servers. Obviously, if I need to talk across the server, I need to spin those up. The idea here in microservices is that mainly you're talking about those boundaries, so the file system, the databases, networks, and basically anything that doesn't live in memory. So if I actually have to go make a network call, I want to test those, make sure those are all good. Questions so far on integration testing? I know it's a little bit different from what you're thinking about in a monolith app. But are we good? I'm assuming so. And we're not taking questions from online, are we?
No.
Bummer.
There's a question right there.
Oh, yeah. Yes. Yep. This is cross-platform. The question was, is this a cross-platform testing? Yep. It definitely is. And again, the testing that we're doing and what we're showing, we did it in Java, but it doesn't necessarily have to mean you have to write your test in Java or anything. These are completely, as far as technology, language, whatever, they're all agnostic.
Although Java's the best, but you don't have to use it.
That was one of those jokes.
Bad dad joke.
Yeah, that didn't get any laughs again. Okay, component tests. That one did.
Yeah.
Go fig. All right, component tests. This is probably a little bit more what people are used to seeing. What we've got here, Martin Fowler. People familiar with Martin? Yes, good. All right, he says a component is any well-encapsulated, coherent, and independently replaceable part of a larger system. Okay, we got some words here that may make some sense, maybe not. So the idea of a component, if I can take it and I can pull it out without really affecting a whole lot, or if I can stub the whole thing, that's a component. If your database is something that you can pull out and replace very easily, great. If it's the logging mechanism, if it's our D&D generator, whatever it is that actually creates attributes, you can pull that out, you can replace it easily. That's a component. So we're going to be testing components.
Did everybody get that last one about the D&D generator, though? A service is a component in a microservices architecture. The difference between this and integration testing is, in integration testing, that service you'll be actually testing against the databases and the HTTP calls. Here, it's just going to be all in memory, but it's that service all in memory. Okay?
That's right. Steve jumped ahead a couple of slides, but that's okay.
Sorry, did I just steal your thunder?
Yeah. Boundaries. Test as much of your component as you can without crossing those boundaries. So like Steve was saying, it needs to be in memory. If I'm talking out of process, across the network, whatever, then you need to mock that out. You need to stub it. You need to create some sort of double or something that you can run in memory so it'll be fast, so you can replace it, so that you can test different kinds of paths, right? How many of our unit tests do we go through and we go, okay, 2 plus 2 is 4, we're good, right? Well, what happens if I say 2 plus 2 is 5? So that's that happy path versus the non-happy path testing. With component tests, the idea is so that you can replace some of those things, so you can test those different paths to make sure if I should be getting error when I input bad data. Am I actually getting an error with bad data, yes or no? So we can test all of those things. Like we said, mock stubs in memory. Questions so far? Got another slide. But if we've got questions, I'll take them. I see pictures being taken. I'll wait just a second. You might want to pose a little bit.
I always pose.
Yeah. Ideal conditions, like I said, everything runs in memory. In process at least, if not in memory, in process. Stubs, mocks, logging, monitoring, all of that stuff. If I can mock it out, I'm going to do that so I can make sure to keep everything local. Again, just reiterating things. We didn't bring up any water, unfortunately. And tests cover both happy path and error path. So I want to make sure that with my green path, everything works, and then I can also test those error conditions and make sure those work as well, those are valid. You don't want to find those at a later stage, or heaven forbid, you roll things out to production and find out later at 2 a.m. when your DevOps guy says, hey, I don't know how to do this, come fix it. And also, you want these tests to be easily repeatable, which is a big part of having everything in process. I don't want to have to wait 5 minutes, spin up the database, seed it with data, all that kind of stuff. I want everything running quickly. That's the name of the game in testing in general, but definitely in microservices. You want things fast. If I'm going to be integrating this into any kind of continuous integration pipeline or something where I want to run all the tests or as much as possible with every commit, I want these things to be running fast. I don't want to wait a day for my integration tests to be running. Yay, water. Component tests. So this is what it is in microservices. Your services using stand-in databases or in-memory file system, whatever it is, to stand in for the actual calls and whatnot. We've got a demo. And, all right, let me know. I'm probably going to have to zoom in a little bit, aren't I? I didn't do that earlier. Do I remember how to do this in IntelliJ? Probably not. Yep.
Any IntelliJ users can help him right now remember how to change the font size?
I know there's actually somewhere.
Eclipse? No, I agree. I'm an IntelliJ. I don't either. I'm an IntelliJ user too. How many are NetBeans users? Anybody a NetBean user at all anymore? It is. It was actually donated to the Apache Foundation.
Oh, that's right. It was. I forgot about that.
Yeah, yeah. And it just graduated from incubation. I'm still an IntelliJ user though. What?
Yeah, that would be cool. There's no Apple on here though. No, they don't pay me enough to have an Apple.
Oh,
I know there was something.
You'd have been a JBuilder user. Orland for the win.
Maybe. Is that F11? Do I get lucky? It is not F11. Nope. It is not. Ah, very good. Someone was thinking. All right. Is that too big, or are we good? Maybe I can see if I can get as much text on here as possible. Right, and we are talking about component tests. So we've got one right here. This is most of it. All right, like I said, Archillion, so this is actually an Archillion test. I'm going to gloss over the Archillion stuff. We'll get to that later and actually dive more in depth with Archillion. So the part that we really care about, because our generator, which actually doesn't have much in it. So our generator is really simple. We go through and this is most of it. Yeah, this is most of it. So what we're doing, really, where is it? Anywho, the idea here is that we've got a character, we've got a whole bunch of attributes that we've got, and then we go and randomly assign numbers between 1 and 17 to the different attributes. So that's what it is. There's not a whole lot there.
It's all in the business class. So
right. Oh, it's in the model, isn't it? It's
that's
not
right.
the generator.
So it's a JAX-RS. How many of you have used JAX-RS? What are you guys all using? I heard the Spring question. What are you guys using if you're not using JAX-RS? Struts. And you all had the security vulnerability, didn't patch it. What are you using then for your REST services? Spring. There's one person who's honest. Nobody's writing REST services? None of you write code. We're not writing Java, so what do you use? Nice. Flask? Okay. So JAX-RS is awesome. It makes you feel hip and happening like the Node.js Express users and the Flask users in Python.
Yep.
Basically what we do is we call a method that says generate character. And we make a path to it with some annotations. What's happening underneath in the class?
I found it. So we've got, if you take a look, so it's all done in the constructor right there.
Yeah, the class, when we call the constructor, we just basically say on the business model, create all these things. Generate all the stuff.
Yep.
Because that's what should care about it, not my web service.
Fair?
Does everybody get the architecture there? There's a JAX-RS handler. We say make a character. That instantiates a character. The character generates all its attributes and then returns that to the request handler. Good? I got a thumbs up in the back. He's voting for everybody since he's the only one responding.
Yeah. All right, what we've got over here, like I said, we've got Archillion, so we've got a small deliverable, a package that we were creating, and then I'm simply exercising the method here. So the make a character for Mongo, which, like Steve was saying, this is our REST endpoint here with JAX-RS. You can see it's a get method. It produces JSON, and you can reach it at /chars or char, depending on how you say it, at /dd. And we actually go through, create the character, set a name, and we've got some debug stuff that we forgot to take out. It's all good.
Because we didn't have testing.
That's right. Tests were written afterwards. Don't do that. Do as I say, not as I do, right? Everyone, children, gets that idea. Then what the service is actually doing when we go through and save the character, that's calling out to the Mongo system. And then we actually include the ID that comes back from the Mongo system, and then we output the attributes just as a flat hash map. So not much here on the component test, again, because it's simple. We want to keep things simple, so there's just little things. You will notice, for those that are familiar here, this right here, the simple character persistence, this is a double or a stub for the actual Mongo system. And if you're really curious as to what it does, it gives us a unique ID, and that's it. So instead of persisting it, it's all done in memory. I actually make this call. It's done via CDI injection. So in the test, we're using this one instead of actually going out and calling Mongo, and it just gives us back a random UUID, which for our purposes as far as testing, it's good enough. And just so that we can say we actually run it, so I'm not sitting here BSing the whole thing. Did that run? That was a contract test. Okay, this is going to take a little bit of time because it's actually running inside Wildfly. Yeah.
And not in Python.
Right, right. So if anyone's familiar with EAP, JBoss EAP, or Wildfly, you saw the logs go by. And we've actually got a green bar up here, and this is green as well. So our tests do actually work. Questions so far about the component tests? Yes?
So if you weren't using Archillion, could you just, the class that calls the Mongo, could you just make that a mock implementation?
Yes. The question is, if I were not using Archillion, could I just make this a mock and do it that way? The answer is yes. I thought about doing that, and then I'm like, I don't really want to get into having to do the reflection and do the injection and whatnot. Forget it. But yes, you most definitely can. Any other questions? No.
Does
Okay.
everybody get what happened there? Does anybody not? Does anybody just not get it but doesn't want to hear it again?
I think they just want us to shut up so they can go to
Get
lunch.
exactly.
Yeah. Contract testing. Well, when you hear the idea of the contract testing, and along with the picture as well, what comes to mind? What do you think? A drive-through? Okay. Men in suits. Why? Why? What are you thinking? What's your thought process here? Sorry? Paperwork? Okay.
Why do we? But I know some people like paperwork for paperwork's sake. But why are we really usually have? Why do you have a contract? So not get in trouble because what have you made clear? Expectations, right? I'm going to do this. I'm going to give you all this money. You are going to give me the deed to the house. There's no like, well, maybe I'll give you the money. You know, like, oh, it's a word of mouth. There's a contract. This is what happens with it, right?
Yep. I heard someone up there, at least I think it was up there, someone said API. Oh, maybe it was in the back. They really are serious about the acoustics not being great in here.
Right.
All right. Yeah. As far as microservices are concerned, contract, we're talking API. So this is public-facing API that we're going to be testing.
Is this contract first?
Yeah, you can think of this as contract first. Yeah. Yep. Now this is not an integration test, and it doesn't exactly deeply test the system. The way that we've got it, we're actually going through and running the whole thing, but it doesn't have to. And what you're going to be doing on this one, you're checking required input and required output. So I want to make sure that what I've got as a client, now this is the important part. I'm not testing this as a service. I'm testing this as a client. So I'm acting as a client talking to my service. I want to verify what I send in and what it sends back is actually what we're expecting. How many people have used public APIs and stuff's not working, or you realize, oh, I'm on V1 and they're using V2 and V1's being deprecated in 2 months? Anyone been there? A couple of people. Yeah. Actually, more than a few people. Yeah. And you also, as much as possible, you want to verify response times, right? How often do you run the service and all of a sudden I'm going, this is 10 seconds, 20 seconds. It should be a simple call. What's going on here? You want to make sure that your services are responsive enough to actually do what you want them to do. And then ideally, consumers should contribute these contract tests back to the provider, right? I haven't seen that done very many places, at least with open APIs, but it would be really handy if I could go to, GitHub was the first one that came to mind, the GitHub API and say, hey, I wrote a whole bunch of tests because I've got this new client. Here are the tests. Please run these against your stuff. So when you change things, when you roll out a new version, you know, one, what you're breaking, and two, where your services are changing. So I know as a client, things aren't going to change. That makes sense to everyone?
And while Jason used, there's too many J names. While Jason used the example of GitHub, you can see how this would work inside an organization as well. Yeah. I mean, because that's what's the hardest part about microservices? Is it technology? No. It's all about people. Microservices makes people stuff even more important, right? And so what this allows for is, if I'm consuming the D&D generator, using something else, like I'm making some new gaming client, I'm going to write my contract test and give it to the D&D generator team and say, this is my understanding of how we're going to talk to each other. I'm going to send you this, and you're going to give me the house, right? Yep. So this is one of the ways to help facilitate that communication between teams. Okay?
Yep. All right, this one I'm going to spend a little bit of time just to make sure that we're completely concrete, and maybe the different colors are coming through, not sure. The idea here is we've got some sort of service, and in this example, our service is returning back an ID, a name, and an age. We've got 3 different clients here. Client A cares about the ID and the name. Client B cares about the ID, the age, and client C cares about all 3 of them, right? So if I've got contract tests, if I'm client A, I want to write a test that verifies whatever I send back. Say I send back, James, right? I want to look people up by name. So I send back James. I'm expecting that the service is going to return back, at the very least, the ID and the name. It may send back more things. It may send back age. It may send back address. It may send back telephone number as well. I don't care about those. What I care about is ID and name. Client B does the same thing, except I don't care about name. I'm looking for ID and age. Client C says, I want everything. Okay? Now, without the client tests on either end, what happens if producer suddenly says, oh, hey, we've got this extra last name field over here, and it's not being populated because we got the full name in here. We're just going to break that up. And instead of name, we're going to call it first name and last name. What happens then? Service failure. Yep, things don't work. My clients are now not receiving things. So client, in this example, client C and client A are going to be messed up. There's no more name field. They don't know what's going on. I've got other fields I don't care about. So as a client, I want to make sure that my producers know about what I'm expecting. And I'm also going to tell them I expect this to return back in 500 milliseconds or whatever it may be. And I also expect this to come back in JSON. If all of a sudden they start sending me XML or binary or whatever, things don't work. No longer in the happy path. Questions? I'm sure people have them. Yes, upstairs. So the question is the contract necessary if I'm only working internally? Are you talking with anyone else, or are you just talking to yourself? Okay, if you're talking to yourself, does future self remember what past self was doing?
Someone should probably hire that person because he's obviously perfect.
I'm going to say yes, contracts are important regardless of who you're talking to. That may be me in 6 months down the road. It may be Steve. It may be someone else over in India or China that I'm communicating with. And we need to understand the contracts, right? We've been using the whole house idea. I want to make sure that I understand my end of the bargain, the bank understands theirs, and we're all in agreement.
Yeah. And yeah. I think the thing is, if your perfect future self knew everything also, not that I would ever do this, but I wouldn't need unit tests either, right? Part of the reason we write unit tests is so when I come back to the code in 6 months and I try to refactor, I can tell when I'm breaking things. Exactly the same thing here. And with microservices, this is based at the service level. This is the unit test at the service level. If you think about it, inter-service communication. This is your unit test because that's all anybody knows about a service outside of that service is what I send and what I get back, and the internal is opaque. So.
Right. I like what Steve said here. The idea, who thinks we write tests to verify correctness? No one.
They knew you were saying
I baited the question, right? Okay. So the idea of tests is not so that I can verify correctness. That's actually a really nice artifact of doing it. The idea is so that I can refactor, so I can change things. And the contract test makes that so. I verify that the contract's right. From a black box perspective, right, if I'm calling in a public API, I don't really care what they wrote it in. They might have written it in Flask. It might be assembly for all I care. I don't know. As long as the contract gives me back what I'm expecting, I really couldn't care less about how you wrote it. Yes?
So if you make breaking changes, do you then update your contract and send it out?
If I make breaking changes, do I change the contract and send that out? That is going to be something that's going to be handled on a case-by-case basis based on what the business does, right? If it's all internal and everything's internal, no one cares about versioning the APIs, yeah. If it's a public API, then you really should consider versioning. We made a breaking change. This is going to be version 1.1, version 2, version 500, whatever it is. But definitely, if it's a public test, then you'll want to look at versioning your APIs. You don't want to be breaking people that don't use your tests or don't use your services all the time, maybe in 6 months someone goes, oh, hey, I really needed that stock quote, right? But it broke, and I don't know why, because maybe I wasn't on the mailing list or whatever. But if it's publicly facing, definitely look at versioning your contracts. Yes? The question is, who's responsible for writing the tests? Is it the producer or is it the client? Is that right? Okay. In the ideal world, as a producer, I would say, this is what I'm exposing, right? Here's my Swagger, or just losing words. Here's the Swagger, or just here's the basic documentation for the API. Clients, you write the tests, send them back. That's the ideal, right? We don't really live in the ideal world all the time, so more often than not, the producers are going to be writing client tests, but they should at least document and give a Swagger API. So that would be what I would consider bare minimum, is just the Swagger or the documentation for the API.
Does everybody know what we mean when we say Swagger? No? So
some yes, some
Swagger, no. Which is now called, I think it's all been migrated to OpenAPI, is that right? It's now called OpenAPI. It's a way that you can write a YAML file and then agree that YAML file can then be used to generate stubs in your code, and also you reverse engineer to generate SDKs to read from that as well. It's kind of a specification for APIs, is what I would call it. It used to be called Swagger. Now it's all OpenAPI.
Yep.
And the other thing is, related to the question from before, and bringing it back to your question, you as a producer should be writing it anyway. Because if you're going to refactor inside your methods, you want to actually know, am I still spitting out? You should write at least some basic ones yourself, right? But I would say any client that comes to rely on stuff, like I really need that, like he's showing here, you should probably write and contribute at least.
Yep. Okay, we're moving on. I just saw you the 10 minutes. Tools. We mentioned Swagger. Packs out there, Pacto, Janus, Swagger, 3Scale, to plug the Red Hat thing. There are tools out there for writing contracts, wow, and going that way. There's also other ones as well. The idea here, again, in microservices, you want to test the request and the response, make sure that the input and the output match what you're expecting. And our quick little demo for our contract test. Now this one should actually be fairly straightforward. I'll show this one again for time. Now this one isn't using anything particularly special. The only thing that I've got here, which may not be familiar to people, is I'm using rest assured. And all that does is it gives me an easy way to test a REST endpoint. What I'm doing here at the top, I've got a service URI that I've just basically hard-coded. The base path, so this is going to be our spec at blah, 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 HTTP, blah, 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 whatever, /ws/character or char. That's the spec that I'm given when we actually perform a GET request with the path of JSON. Then I should assert that the body comes back and the name that comes back in that payload is JSON. It's really simple, really easy. I've got some other ones in here that are a little bit more in-depth to verify that we actually have the right things. So I want to make sure that the strength is actually a number that's greater than 0. Same thing with hit points. I want to make sure name's a string, class, all of that kind of stuff is a string. So that a little bit more in-depth. Again, there are other tools. I could have done this with Pact. I could have done some Swagger stuff. I could have used 3Scale. I could have used a whole myriad of other tools. This is just to show that as long as you can inspect a REST request, then you can use that for your component or your contract tests. All right, Steve's up talking about end-to-end testing.
Thank you. So end-to-end testing is exactly what it sounds like. You're basically testing all the integration of all your microservices, right, in whatever the user is using. And, oh wait, wrong button. We're not going. Psych, no demo for you. End-to-end test, it's the whole enchilada, like I said. They're difficult to write. And when I mean difficult to write, I don't mean like technically difficult to write. Like it's not hard to write a Selenium test. What's difficult is you're usually testing against some web page, right? And how many of you have done web development? And how easy is it to get browser support to work well across all the different browsers? Right? And so that's exactly what's happening here. Because what you're basically doing is you're doing a web request to whatever that interface is, and then you're trying to get the HTML that comes back and test something specific about that HTML if you want to make this automated. Otherwise, you're doing exploratory, right? So how many of you have actually even tried doing UI testing in an end-to-end test, like with Selenium or something else? You tried it? How much fun was it? Yeah, it was awesome? Yeah, right. The problem is, like you say, click this button. First, find the button on the page that has this word on it. Click this button. Wait up to a second. Then, when the response comes, go down 150 pixels, then go 20 pixels to the right, and the color should be green. This hex code. And how many times do you think the designers and stuff like that actually check the hex codes when they make minor changes? Almost never. So your test, this brings us to the last point about this. So I already covered the slow. Oops. I already covered the slow because you have to do all this waiting for the web. But they're also really brittle. The designer changes the class name for a tag. Like it's easy to write an XPath expression. Go in and find it, walk the tree in the DOM and find this tag. Well, so somewhere in the tree, the designer changes the class name. What's happened to your test? It's broken, right? So these are really brittle tests, which make them really hard to write. They're important. I'm not saying you shouldn't do them, because this is actually what your user is experiencing. So all your REST endpoints working great doesn't really matter in the end if the web app doesn't work, right? So you do need to write them. I'm just giving you a heads up. These are not going to be the fun ones to write and to implement. You can use public API endpoints, but that's kind of what we were contract testing. This is more about Selenium and robots, and JMeter does some of this as well. JMeter is very flexible. Have any of you heard? Most of you heard of JMeter? So a lot of people use. It's a Java framework that actually most people use for load testing. Right? They'll say how many requests per second, and they'll give different requests. But it can actually return HTML, and you can check what's in the HTML. It will not do GUI testing, though. Like if you actually need to know that you're getting the right image back time and time again, like I used to work in mapping, and you always had to make sure that the same exact map came back, that's a pixel test. Okay? End-to-end testing microservices, this is you're using browsers, mobile emulator, or JMeter type testing, right? So I'm not going to say too much more about that. Does everybody get end-to-end, though? Okay. Have fun with it. So in the beginning, I showed the pyramid about how they were kind of put together. This is from Fowlers. The best way we could summarize this is where to actually spend your time pyramid, right? So this is how much effort you should put into these different types of testing. And what Fowler says is most of it should be unit tests still, right? Because that kind of protects you at the lowest level. Then it's the integration test. Who remembers what the integration tests? What's the difference between integration and component tests? You guys are all repeating this. After lunch, we'll be redoing this again until everybody gets it right. Go ahead. Which one was that? Yeah. Integration is actually testing the connection to the database, is actually testing doing HTTP requests and expecting some response. Right? And that actually kind of makes sense because, yes, the component testing is kind of nice, but when you're doing services and stuff like that, it's nice that I can mock, but what really matters is I actually want to make sure I can connect to my database that I think I'm connecting to, or I can make an HTTP call and get a response.
How long did we spend on that one?
How long did we spend on that one?
Yeah, talking to the database, that was a couple of days.
That was all our debugging for a day and a half, was trying to get the database connection to work. There was Mongo and the way, yeah. I think in here, the contract test is kind of somewhere right there. It's in between end-to-end and component, right? Because contract is actually, this is these two, component and integrate. The question was, where's contract test, in case you couldn't infer. These two are basically discrete within the service. A contract test is testing between services, so it's going to come basically here. End-to-end might be something like actually testing that web page that we saw, which calls all the services together and then displays a web page. Contract would just be between like the D&D service and the Mongo service. Does that make sense? That's the contract test there. You know what? So I'm not Martin Fowler, but I'll pretend to play one on TV. I would actually say that this is how much time you actually spend. I would actually say, so wrong graph. I was talking in the other graph where they sit. In this graph, I would actually put them as important as integration tests. They're more important to me as a microservices developer. That's actually much more important to me than a component test. Because that's actually, the only reason I'm making a service is that someone's going to actually use it. And like I said, for microservices, I think that of contract testing as my unit test with the rest of the world. Like if it's not requesting and responding in the right way, what's the point of all the other stuff inside? Yeah?
So when you mentioned the Swagger testing and the contract testing, are you saying, you go in and you look at the Swagger spec and you get the try it now button or run a curl, and in his example, you get back the full name instead of just name? Is that?
I'm not quite sure what you're saying. How would you actually go about doing the testing and contract testing?
How are you doing your Swagger testing?
Using one of the test frameworks that he, like one of the things that he used before, or Swagger, I think, can generate APIs, right? So then using that with some sort of testing.
To make sure that you don't get like the full name back.
Exactly.
Yeah. Yes.
Yeah.
Yep. Exactly.
Okay, so we got to wrap up. I think we only have a couple minutes left. I'll let Jason take. You want me to just do the last ones?
Yeah.
Okay. So almost all of this you can put into. I'm assuming most of you are, since you're large companies, do CI/CD. Is everybody here almost from a large company? Yeah. So almost all of this can fit into your CI/CD pipeline. You probably don't want it running a day though, if it's supposed to be in your CI/CD pipeline. Maybe you want to contract the number of tests though, right? Or tune them or something.
Or do a smaller subset.
Yeah. That goes with every push.
Right. Yep.
Archillion, awesome, open source. It's a comprehensive testing framework. Is that how you would describe it? What else would you throw in?
The basics for Archillion is that all of your tests you can run inside of a container. So a container or a server. So if I'm writing Java EE or if I'm running Spring or whatever, I can run those actually inside a booted up system where I have all those integrations. If I'm running inside EAP or Wildfly, I've got a JMS connection, I've got a database pool, I've got transactions. I can actually run all of those inside of a full-blown container. So when I'm going through and actually running the components, I don't have to mock out my transactions. I don't have to mock out the JMS calls. I can run those inside a production-like system and run my tests in that same area. Okay, open source. Again, go check it out. Good? I'm here today. You can talk to me later about it if you're interested.
Last slide. These are the take-home messages for you, because we haven't talked about much, so I just thought I would reinforce what we actually talked about. Try to cover the whole suite and then expand within levels. And what I mean by that is try to cover the whole pyramid first, and then over time expand across. For any of you that read the Pragmatic Programmer book, which I highly recommend to everybody, this is called tracer bullets. Right? You want to make sure you can go all the way through your entire test suite to make sure that you can do it, and then add pieces along the way wherever you need them. Don't try to build everything all at once. Okay? Bad idea. There are tools to help you. Please do not engage in not invented here. Okay? There are lots of tools with people who've done lots of this work before. Make sure to take advantage of them. And the last point is, actually, you can do this. If I can do this, you can do this. Right? So take it slow. Bite off little pieces at a time, and I think this would help you a lot, especially as you start to take on microservices, which can be overwhelming, right? So do it small in the beginning. And there's the link to the slides again if you want to take another picture. Thank you very much.